The recv function is a very common network function that you probably use every day. But have you ever wondered, if the network data hasn't arrived yet, what exactly is this function doing? For example, when the program executes this line of code, it wants to read data from a socket. But the data hasn't arrived yet. At this point, the recv function cannot simply return data out of nowhere. So the program enters the kernel. The kernel checks this socket and finds that there is no data. If this socket is in blocking mode, the operating system puts the current thread into a sleep state. However, the CPU is not occupied by this thread. On the contrary, since the current thread can't do anything right now, the operating system can hand over the CPU to other threads. When the network data finally arrives, the network interface card receives the data. The operating system kernel processes data and places it into the socket's receive buffer. At this point, the kernel wakes up the thread. The thread regains the CPU, the recv function continues execution, and returns the data to your program. This raises a very interesting question. If a server has 10,000 concurrent connections at the same time, do we really have to make 10,000 threads sleep on 10,000 recv calls, respectively? To answer this question, we have to touch upon technologies that later emerged in network servers, such as I/O multiplexing, event loops, and APOL.